I'm Nick Neisingh from Tatlo Road Farm. This is my farm here. I farm it with my wife. We've been here since 2012, so going on 10 years now.
My name's Niki, and this is our farm, Tatlo Road Farm in Crofton.
My name is Raelani Kesler, and I'm a master's student and graduate research assistant with the Sustainable Agricultural Landscapes Lab at UBC. One of the challenges being felt by growers given the changing climate and all of the changes that we're seeing to precipitation patterns in this part of the world, where we're getting more rainfall in the spring and the fall, or the shoulder seasons. Growers who work in annual systems like vegetables or cut flowers, these shoulder seasons are important times to move fields in and out of production, and this is traditionally done with tillage. And having wetter soils during this time creates issues for soil workability, so we can be more damaging to soil structure if we are using mechanical tillage during times when the soil is too wet. And so questions have arisen about how to keep soil covered over the winter in places on the farm or in situations where cover crop can't be readily established. And so the use of silage tarps has been getting more popular as a way to provide that cover, but doesn't necessarily need the mechanical element to get a field in and out of crop production from one year to another year. But we don't have a lot of information about the impacts of these tarps on some specific soil properties. So this project was aiming to answer some of those questions.
Yeah, we started using overwinter tarps about 6 years ago. I think initially just because we found with certain crops we weren't able to get them out soon enough to then establish a winter cover crop. So we figured having some kind of cover on the soil was better than no cover at all. So both to protect from leaching and then just also like a physical protection maybe from some of the compaction of all the rains that we get in the winter. But then we've found some other nice side benefits to using the tarps that we quite like, depending on in the spring. When we remove those tarps, sometimes those areas would be more workable or drier, and so we could get crops in sooner. So there was that nice sort of benefit on the flip side.
So in the study, we measured the amount of soil water, soil nitrogen, and electrical conductivity underneath silage tarps, and also in fields that were cover cropped. So our research project employed an experimental regional approach. So we had two different designs. We had two farm partners that hosted larger trials where there were many tarps and many cover crops on one farm. We had a lot of replication and were able to collect a pretty robust set of data. We also worked with 12 regional farms in 3 areas in the province, in the Kootenay Mountains, on Vancouver Island, and in the lower Fraser Valley. And all of these are working farms, and they each hosted one tarped and one untarped plot. And there we were able to look at some of the variability in soil texture and climate that might impact our findings. The regional component was really important to this project because it created a lot of face time between the research team and the farmer participants, so we were able to incorporate their feedback and their questions in different points during the project, and then also allowed us to ground truth some of the findings that we saw at our experimental sites to see if those results changed depending on the farm system or the location. And one of the important things that we found was that these tarps are affecting water dynamics over the winter. So in our trial on some farms, we found that when we went in the spring to take these tarps off and take some water measurements, the ground was actually much wetter under the tarps than it was on uncovered ground. We think that the ground is wetter underneath these tarps in the later spring because the water hasn't been allowed to evaporate underneath these impermeable tarps, whereas in uncovered ground, there's evapotranspiration happening. Cover crops or live roots are pulling water up from the ground. In another part of our trial where we were able to measure soil moisture continuously over the 2 years, we did see that the silage tarps were keeping the ground drier over the winter. And then there was this pivotal point in early spring where uncovered or cover cropped ground started to dry out quickly, whereas the silage tarps were keeping the water in. And so one important management decision for farmers is the timing of when to remove these tarps if they're trying to target a particular soil moisture threshold.
We time our removal of them based on what's going in there. And so we try to remove the tarp like a week or 2 or 3 possibly, just depending on the time of season, because it is still a little bit moist, so we want it to dry out a little bit more. And then, but we don't want to let it sit open for a really long time and say let weeds come on, or let it get rained on and maybe the moisture level changes to a way that we don't want it. So we take them off just in time to get the next crop in. And in the spring it's like we take it off, and it might help that, after a few days of nice weather, it's actually a little bit drier, and then there's no debris to break down, so it's ready to go. Later in the season, say like sometime in early June, we take that tarp off, and it's actually got a nice level of moisture, and there's no weeds, so we can just do a quick cultivation and plant into it.
In the study on one farm that was particularly coarse textured, or had a coarse textured soil, we did see that in terms of tarp removal, there was a period of time in kind of early March where the water dynamics started to shift, and that would be potentially for this region in a year like this year or like the past couple years, a good target date for removal if you're trying to manage these tarps to minimize soil moisture. Another research finding that came out of this project was the observation that nitrate's a plant available form of nitrogen. These nitrates were higher underneath the tarps in the spring when we pulled them off. So we found that the tarps are potentially protecting some residual nutrients from leaching over the winter, and in essence holding or storing some nitrogen that may be available to growers in the following spring.